bunch of different transformations. And last time that we had class, we talked about having a composition of transformations. Just so we're clear, when you had a composition of transformations, actually we'll leave it like this. What would it look like if we had for our composition, or if we had a transformation? What is this telling us? What is this telling us to do? Take a look at what's up there. We worked on last time we met. What is that telling us to do? Be as specific as you can. I don't need actual values, so don't worry about that part, but walk us through what your process would dictate happens. Great, we're going to start with our reflection of the point over the x-axis, and then what would you go through and do? Rotate 270. Remember, this gets done first. That's our first if there is a composition of transformation. But that can be tough to remember. So we're going to say instead is, not only could we do that, we can also just list it out as separate steps and put a then in between them. That's kind of baiting it down, but we can go through and do that. Let's take a look at our figures now and see how we would list this out. In the diagram, those three figures are congruent. Which sequence of transformations maps to figure 1 onto 2, and then 2 to 3? So we're going to start off here. I'm looking to go from figure 1 to figure 2, and then figure 2 to figure 3. So this is where it's going to be a little bit awkward. Let's start with, how could I go from figure 1 to figure 2? What's getting done to go from figure 1 to figure 2? What type of transformation is done to go from figure 1 to figure number 2? I'm going to show it this way. From 1 to 2, what did we do? We've got 2 people, 3 of us. What would we go through and do to go from, just to make the shape at 1, go to 2? It looks like it might be a reflection. Would that work out? Not wrong. It kind of looks like a reflection, but the problem is also the ordering of the points didn't change. So if this was a reflection, B, if that's here, B prime would have to be here, and it's not. It's not a reflection. It's going to be a translation. Now, this isn't labeled axes, so I would say this is a translation to start. And if there's not numbers, we can just go through and indicate the vector motion, which would be from A to A prime. You also could have put what, there's actually 6, I think, choices that would work. What other vectors would you have indicated? D to D prime, F to F prime, any of those letters to their prime. Now take a look at what's there. We need to go from figure 2 to figure 3. Take a look at figure 2. Take a look at figure 3. And how can I go from figure 2 to figure 3? Got 1, 2, 3. So I'll start off with, you're right about the rotation. So it's going to be a rotation. Now here's the part to figure out how many degrees it's going to be. Just go through and I'm going from A prime. Oh wait, sorry. Is it from? No, we're going from 2 to 3. So it'll be from A prime to A double prime. That's going to be our rotation. Now, we can say it a couple different ways. If you're going to say 90, you have to say it's 90 degrees clockwise, or 270 counterclockwise, which would be this way here. I'd say probably the easier way is to go through and say it's a rotation. I'm going to say of negative 90 degrees. We're going, remember hang on please. Our quads go 1, 2, 3, and 4. Our quads go 1, 2, 3, and 4. That's the ordering that we go through in half. So, when we open up angles of rotation, remember angles of rotation go this way. This would be from 0, this would be a 90 degree, this would be 180, and this is 270. Full circle is 360. Now I'm starting off here. I could say a rotation of 3 quads, which would be 270, or just going backwards 1 quad, which would be, you could do either of them. You could also put on there negative 90 degrees and indicate the direction itself. You could say clockwise or counterclockwise. If you don't say it, though, it's assumed to go clockwise to stay motionless the clock. Or counterclockwise, excuse me, opposite motion, you go from quad 1 to 2 to 3 to 4. Do we have questions on that one? Okay. Take a look at what's there then. For the next one, read what's there for 2 and see how far we can get. I labeled my figures. It says we need to find a way to make A, B, C, D go to A double prime, B double prime, C double prime. I'm going to start off and list out my transformations to go from figure 1 to figure 2. Take a look at what's up there. How could I get from figure 1 over to figure 2? That's 2 of it. That's it. 3. We go through and say, that, I think, is my very first step. I list out reflection over the x-axis. That gets me over to, from 1 to 2. X-axis reflection. And then to go from figure 2 to figure 3, I also have to look at that and say, how can I go from this to that? Hands up, please, when you can identify how I would go from figure 2 to figure 3. Yeah, it's going to be a rotation, a spin from here to here. Notice our orientation does not change. We're just rotating. So this would be a rotation. You could say a rotation of 90 degrees. What else could you say besides a rotation of 90? You could also say negative 270 as well. Questions on that one? Okay. Next one up, write a sequence of transformations that match triangle 1 to triangle 3. We need to list out what that would be. So take a look at what's there. Focus on going from 1 to 2 in the beginning. And hands up, please, when you can tell me how I could get from 1 to 2. How could I go? Just focus on moving that triangle from position 1 to position 2. You can deal with the other parts later. By what? So you're going to add 1 to the x. Okay, so you take the x minus 6 and the y minus 5. Is that right? Is that what you're saying? Okay. You could also give this out as a big T with a negative 6 comma negative 5. How can I go from figure 2 to figure 3? Take a look at what's there. You're going now from figure 2 over to figure 3. Any transformation that works is fine. You can tell us how we can go from 2 to 3. Awkward. We've got to go from here to here. Got one person in top. Perfect. You got a second translation now. And you said it was, I want to get that right. Did you say it was positive 14 and then negative 3? What were our numbers? Positive 3? Okay. Was that all that difficult for us? No. Next one up. You're given that triangle. And it goes from M to M prime, then to M double prime. What sequence of transformations could I do to go from M, EC to M prime, E prime, T prime, and then the second one to go the other one? So I guess if I were doing this out, I'd start, maybe even just look at the individual points and see what conclusions we can reach. We start off at M, which was negative 7, 2. So. And that got mapped onto M prime, which became negative 7, negative 2. And then M prime, which was negative 7, negative 2, gets mapped onto M double prime, which was negative 6, 0. That's looking at one individual point. You could do the same chain with the others. I just need to go from M to M double prime. How do I make that happen? You got 1, 2, 3 of them. Look at what's there, the point. You can graph it out if you need to. You can graph all of them out if you want to. How do I go from M to M prime? Well, so to start off with, this would be an x-axis reflection. On the point, what was that point? Negative 7, 2. And that would give us the point, negative 7, negative 2. So that one works. By the way, does that work on all of the points or just our first one? Don't look at me. Does it work on all of the points? Does the same rule apply to from A to A prime? What about T to T prime? Okay, so it's got to work for all of them, not just some. So does that work for all? Great. How do I go now from M prime to M double prime? And that same process is going to have to apply for the other points as well. We've gone through, and just so we're clear, we can talk about rotations, reflections, translations, and dilations. How could I go from negative 7, negative 2 to the point negative 6, 0? Hey, what did you say?
Go to one condition of x plus 1 and y
plus. And does that hold true on M prime to M double prime? Yes or no? Does it work for A prime to A double prime? And does it work for T? No, E. Does it work for E prime to E double prime? Yeah. Does it work for all of them? Okay. So, we got too difficult. We got one more. Get number 5 a read. lots of points out if you need to. Remember that rule, that type of transformation, it should hold true, not just for the one point, but all of them. Should at least be able to get that very first transformation that we get from P to point P prime. If I just can identify what the first transformation would be, go from P to P prime, we've got three people. What are you doing with that? Translating across the line is called A. Yeah, the reflection over the line, y equals x. How can I go from the point to -5 and draw it out if you get stuck? The visual's not there. That's the part, frankly, that's going to catch some of us quitting on. Graph the point out if you need to. 2 -5 is in which quadrant? Over 3, down 5. Which quadrant is that put me in? 4 down here. We've got 2, -5. And we need to go to the point 5, 2. No, don't say you don't get it until you go through and draw it. How do I go from P prime to P double prime? What could we go through and do? Yeah, I go through and say a 90-degree rotation. Or you could rotate it. Those are two that you would need. Questions on that one? All right. Go through, please. Turn it over. We need to keep going with these transformations. See how far we've got. Let's describe the composition of transformations that will map these onto each other. So, what do you think would happen in 6A? It's going to be two transformations. How could I go, from, this we'll say DEF is what it wants us to start at. So how do I go from that one to the other one? There's two different ways that you could go about doing it. What's one thing that we could do? There's going to be a dilation involved. I want to do something before I do the dilation part. Yeah. I wouldn't do, the rotation wouldn't work because this segment here would map onto EF. MN and EF fall on top of each other. That might help. First thing that I would do, doesn't matter the order of these transformations, I would advise an x-axis reflection, and then a dilation by a scale factor of 2 centered at the origin. And the way that you can tell that is, use that same trick as before. If the dilation is centered at the origin, to go from the origin to point D, I would go back 1, up 1. To go from the origin to L, which is what it would map onto, I have to go back 2 and down 2. So that movement from the origin, that distance, multiplied by what scale factor? 2. How about our next one? Take a look at B. What would you think B has in it, if we're going to go through and express that as a couple of transformations? There's more than one way. And by the way, pay attention to the letters, because D, E, F should fall on top of L, M, N according to that order. So D falls on top of L. And so on. What did we go through this thing? Now, we could do that. So here's my problem with that. I'm going to sketch the line x equals -1 in right now. Right? If I do that as a reflection, here's our problem. The distance, like from, I guess, here over is 2 units. This one's only 1. So it doesn't split it. 12 cents might be what we should start. If I do a rotation of 180, N would sort of spin around and fall on top of F. Should N and F fall on top of each other? Yes. So I'm going to guess that that's a good start. What else would I need to do? So we're going to start off with a rotation of 180 or negative 180. Then what gets done? You did that rotation. Careful. If that's the original, that's what it becomes. What would we dilate by? My guess is that some scale factors are doubling. Because this is what I started with, and it's smaller than what I ended with, so that dilation needs to be bigger than 1. Questions on that part? Reflection, we carry the square on the square. Or we take a look at 9. We'll do 9. What is a single transformation that I could use to go from A to B? Yes? I say it's a rotation of 90 degrees. Here's one way to check if they are 90. Other things that we can do to show the rotation. By the way, Jack, you're saying that the rotation would have is what is its center? Where's the rotation based out? Origin, yes. Easiest way to check is to sort of go in, and you can see it, like the distance maybe from here to here. I guess if I draw this and that, what type of angle should I have between them? 90 degree right angle. And is that what ended up happening? Yes or no? Yeah, I could also do the same thing with like the hypotenuse endpoint. Hypotenuse. That was the word. You can do the red one here, which would be this point here, and that point, this point here, and that one there would also be in red and give you right angles. That's what you can see. It's a rotation. We went back 90 degrees. I think that answers the first one. So that's a rotation of 90. What are the coordinates of triangle AB after we reflect it over the x-axis? So that would be A prime. I guess we don't have. We're going to have to just figure out which coordinates that we label. So you can give me one ordered pair that we would have just one after I reflect A over the x-axis. What's one point that we would have? Yeah, see? All right, so we'd have the point 2, negative 1. What's another ordered pair we'd have on this? 2, negative 3. Perfect. We've got one more to go through and get. Connecting if it wanted you to. Did it want you to draw the triangle or just state the points? State the points? Oh, graph it also? Perfect. So graph it out as well. Notice, by the way, did the orientation or ordering of the points change when we did our reflection? Try counting around, circle, and count around the same way in both figures. That ordering, I believe, changes. In that diagram, graph and state the coordinates of triangle B after a 90-degree rotation. So, if I'm doing this, and we can do little pin loops out to try to make it happen. I go to get from the origin, I go up 2, back 1. So going here, I'd have to go back 2 and down 1. That would be one of our points. So what is that going to put us at what point? -2, -1. And then the next one, we went through and did that. I go up 2 and then back 3. So I go down 2, go back 2 and down 3. So that puts us at what order pair there? 2, negative. So negative 2, negative 3. And then our last one up will be sort of that one furthest away. I will go up 2, 3, 4, 6, and then back 3. So I'm going to go back 6, 1, 2, 3, 4, 5, 6, down 1, 2, 3. Your dot there, and that would be the newest one, and that would be negative 6, negative 3. Is that what we have? Yes or no? Is that tough for you? Now, what's the toughest thing to do? Right, the number of them that are there. All right. Let's go through and read this. 10 after. What time do we get out? So, you did dilation, you did a worksheet on dilation last class, is that right? So, take a look at what's there and get started, please, on those very first questions. It should say reflections at the top. So you're going to be graphing that out, which means you have to label the axes. You're reflecting over the y-axis. I maybe want to make mine in the middle. You might need to use a scale of 2 to fit the point. I'm not 100% sure where these points would plot. Looks like 4, negative 6 would be in quad 4. 14, 2 would be in quad 1, and so it's 6, 12. I don't know if you have enough squares. My guess is you might. If not, you can count by scale factor 2. You can go through that through there. You've gotten to almost 20 after. No, it's at 23, right? Oh, your nights are today. You got about 5 minutes. Put them to 4 streets. Turn to each other. You can work with each other. Finish this guy up.